So often we would like to do the same calculation over and over again, but maybe with different values for some of the identifiers. So in order to avoid having to write the program text over and over again, we introduce the concept of a function. So here is the function sqrx calculates x times x. So function is declared with the keyword fun, F-U-N, up until end. We have here first the header between braces, the name of the function sqr and the arguments. Here there's only one, x. And then the function calculates the expression x times x. So this is the function definition. So I feed this to the system. And now I can display the browse, and I do square of 10 here. Remember, function calls, like procedure calls, have the braces surrounding them. This displays 100. So square of 100 of 11 is 121. It also works for different kinds of numbers. 10.1 gives 102.01. So this lets me introduce two kinds of numbers in Oz, the exact numbers, which are integers, and the approximate numbers, which are called floating point numbers, which approximate real numbers. So these two sets of numbers in Oz are completely separate, and there's no mixing between the two, no automatic conversion. So the multiplication operation, when given an integer, will return an integer. When given a float, will return a float. So let me define now a function which does a little bit more. Here a function sum digits, which takes an integer n, which is a 3-digit number, and it returns the sum of the 3 digits of n. So in order to do that, I have to get the 3 digits of n. So for example, this is done using the functions div and mod. This is division and modulo, which work for integers. So for example, I can do n mod 10. This is the lower digit. And then I can do n div 10. This divides the number by 10. And if I do mod 10, this will give me the second digit. And then I can do n div 100 mod 10. This gives